A ship nearly the size of an aircraft carrier, built to land thousands of Marines where no port exists. This is not just the largest vessel for amphibious assault in the US Navy. It is the answer to a mission that once seemed impossible. Since the first Tarawa class launched in 1976, these floating fortresses have changed the rules of war at sea. But why do they need to be so massive, and what challenge pushed the US Navy to build ever bigger? The true scale and purpose defies what most people think. World War II left a lasting lesson for the US Navy. Winning at sea meant nothing if troops and equipment could not get ashore. In places like Normandy and Iwo Jima, American forces faced brutal resistance, not just from enemy fire, but from the sheer difficulty of moving men and armor from ship to shore. Beaches turned into bottlenecks, shallow reefs, mines, and the lack of ports exposed landing craft to danger and delayed the arrival of reinforcements. Even with overwhelming naval power, the ability to project force onto land remained limited by the tools of the era. By the 1970s, military planners knew the old approach could not keep up with new threats. Traditional landing ships were too small, too slow, and too specialized. The Navy needed a platform that could combine the strengths of helicopter carriers, landing docks, and command ships. Something big enough to carry an entire Marine force, launch aircraft, and deliver heavy vehicles, all from a single hull. On May 29, 1976, the USS Tarawa LHA-1 entered service, answering that call. At about 820 feet long and nearly 40,000 tons, Tarawa matched the size of a World War II fleet carrier, but its mission was different. Move Marines ashore rapidly, by air and by sea, without relying on any port. Tarawa's design combined a massive flight deck, a cavernous hangar, and a floodable well deck for landing craft. For the first time, the Navy could launch helicopters and surface connectors side by side, delivering troops and armor directly onto hostile beaches. This new ship type was not just a bigger vessel, it was a new answer to the sea-to-shore problem, setting a standard that would shape every amphibious assault ship to follow. Size alone doesn't capture what sets these ships apart. In today's fleet, two classes of giants dominate the US Navy's amphibious force: the Wasp-class LHDs and the America-class LHAs. Each is a floating stronghold designed to serve as both an air base and a launch platform for amphibious assault. The numbers tell the story. A Wasp-class ship stretches 844 feet from bow to stern, and, fully loaded, weighs between 40,358 and 41,772 long tons. The America class, slightly longer at 855 feet, tips the scales even higher, up to 43,745 long tons in its latest versions. Both classes dwarf the landing ships of previous generations. For perspective, their length rivals that of a Nimitz-class aircraft carrier from the 1970s, yet their mission is specialized: to enable a Marine force to move from sea to shore anywhere in the world without relying on a port. Displacement numbers matter here. The extra weight isn't just armor or steel, it is aviation fuel, vehicle storage, medical facilities, and the infrastructure needed to support more than 2,000 Marines and sailors for weeks at a time. While the Wasp class balances a large flight deck with a full-sized well deck for landing craft, the America class pushes the envelope further. Its early models sacrifice the well deck for even greater aviation capacity, while later ships restore the well deck to combine both strengths. Whichever class you measure, these ships represent the largest, most versatile amphibious platforms the Navy has ever built, purpose-built to deliver power ashore by air and by sea, at a scale unmatched anywhere else. Move a Marine force from ship to shore, anywhere in the world, without a port. That is the mission the Navy gives its largest amphibious assault ships. Every detail of their design exists to make that mission possible, quickly, reliably, and under fire if needed. The flight deck stretches nearly the length of the ship, supporting a constant rhythm of helicopters, tilt rotors, and short takeoff jets. Below, a hangar the size of a city block holds aircraft waiting for their next sortie, with elevators moving them between decks in minutes. At the stern, the well deck forms the ship's hidden engine for surface assault. Flooded by seawater, it allows landing craft to float in and out, loading up with tanks and vehicles, then racing ashore. Vehicle storage spans multiple decks connected by ramps wide enough for heavy armor. Cargo elevators and passageways keep supplies moving to where they are needed, whether it is ammunition to the flight deck or rations to the galley. Medical facilities mirror a small hospital ready for combat casualties or disaster relief. Command centers bristle with screens and radios, coordinating air and surface operations round the clock. Berthing spaces, galleys, and workshops sustain more than 2,000 people for weeks at sea. The anatomy of these ships is no accident. Flight deck, hangar, well deck, vehicle stowage, and command spaces work together as a single system. The goal is to deliver Marines, their equipment, and their support ashore in a rapid, repeatable cycle, by air and by sea, wherever the mission demands. Designers face a tough choice with every new amphibious assault ship: maximize aviation or preserve the ability to launch surface connectors. The America-class LHA, especially in its earliest form, leans hard toward AIR power. By removing the well deck, a massive compartment at the stern measuring roughly 266 feet long, 50 feet wide, and 28 feet high, the first two America-class ships gained extra space for aircraft, fuel, and maintenance. This allowed them to operate a formidable mix of aircraft, including F-35B, Lightning II fighters, MV-22 Ospreys, CH-53E Super Stallions, and a suite of attack and utility helicopters. The flight deck and hangar became the heart of the ship, with crews working around the clock to keep sorties flowing and maintain readiness for vertical assaults. But this air-dominant approach came with a cost. Without a well deck, the ship could not launch landing craft or deliver heavy vehicles directly to shore. Operational feedback from Marines and Navy planners soon made it clear: flexibility mattered more than pure aviation volume. The next evolution, starting with LHA-8 Bougainville, brought the well deck back. Now the ship could once again balance air and surface assault, giving commanders more options and restoring the full range of amphibious capability. LCAC landing craft air cushion are the high-speed workhorses that turn these ships into true amphibious assault platforms. With a payload of 60 to 75 tons, each LCAC can haul an M1 Abrams tank or a platoon of armored vehicles straight from the ship's well deck to a hostile beach. And speed is their edge. Fully loaded, an LCAC can reach more than 40 knots. That is over 45 miles per hour, fast enough to cover 25 nautical miles from ship to shore in under an hour. The numbers add up quickly. A single WASP-class ship can cycle 3 LCAC craft through its well deck, each making 4 to 6 round trips per day. That means up to 18 sorties in 24 hours, moving as much as 1,000 tons of combat power ashore before the first sunset. For the ship's crew and LCAC operators, this tempo demands precision, loading, launching, and recovering craft in a rhythm that keeps the assault moving forward without pause. Life aboard an amphibious assault ship is sustained by a complex web of systems and people working around the clock. A WASP-class vessel carries a ship's company of 66 officers and over 1,000 enlisted sailors, plus nearly 1,700 Marines, numbers that can surge even higher during operations. Every day the galleys prepare up to 18,000 meals, drawing on vast storerooms and refrigerated spaces that stock weeks' worth of food. Water production reaches up to 400,000 gallons per day, supporting everything from hydration to medical care. The ship's medical facilities rival a small hospital, with multiple operating rooms, intensive care beds, and the capacity to treat dozens of casualties at once. Maintenance teams keep engines, generators, and aviation fuel systems running, while logistics specialists manage the flow of ammunition, spare parts, and supplies. At full speed, these ships can exceed 20 knots, repositioning an entire amphibious group across hundreds of miles in a day. Self-defense is layered. Ram and Sea Sparrow missile launchers, Phalanx, C-9WS, and heavy machine guns stand ready, but ultimate protection comes from operating as part of a larger group. Alone, even the largest amphibious assault ship depends on its crew, its systems, and the support of the fleet to survive and accomplish its mission. Right now, these ships anchor U.S. power wherever ports don't exist, projecting force, but also deterrence, in an unstable world. As global flashpoints shift to coastlines and contested islands, the ability to land a force from sea remains a question of security. Mobility decides who shapes tomorrow's battlefield.